Hey, what's up everyone and welcome. Today, we are going to crack the code on one of the most useful tools in your entire trigonometry toolkit, the sum and difference formulas specifically for cosine. We're going to see how they work, and why they're so incredibly powerful. All right, let's get into it. So let's just kick things off with a problem. How in the world would you find the exact value of the cosine of 75 degrees? I mean, go ahead, picture your unit circle. You've got 30 degrees, 45 degrees, 60 degrees, but 75? Nowhere to be found. So it kind of feels like we're stuck, right? Well, not exactly. Here's the big secret. We can actually build these unfamiliar angles using the ones we already know and love. And if you look closely, 75 degrees is really just a simple sum of two of the most famous angles on the unit circle, 45 degrees plus 30 degrees. This right here, this is the secret door, and the formulas we're about to learn are the key. To get that door open, we need the right tools. And for us, that means the cosine sum and difference formulas. Now, I know they can look a little intimidating at first glance, but trust me, they follow a very specific and actually pretty easy to remember pattern. Okay, here's the first one, the cosine sum formula. Now, take a look at the structure. See how the functions are grouped up in these matching pairs? You've got cosine cosine and then sine sine. But now, look at that sign in the middle. To find the cosine of a sum, you actually subtract the two big terms. It feels a little backward, and that's probably the most important thing you need to burn into your brain about this formula. And this chart just shows it so perfectly, especially when you compare it to the sine formulas you might have already learned. Remember, sine likes to alternate functions. You get sin cos, cos sin, and it keeps the same sign. But cosine groups them up, cos cos, sine sine, and, this is the crucial part, it uses the opposite sign. So if you're adding angles, you subtract in the formula. If you're subtracting angles, you add. Okay, so theory is great and all, but let's actually put this thing to work. We're going to take that sum formula and finally solve our original mystery. What is the exact value of the cosine of 75 degrees? So let's just walk through this one step at a time. First, like we already figured out, we break 75 degrees down into 45 plus 30. Easy enough. Step 2, we apply our new formula. That gives us cosine of 45 times cosine of 30 minus sine of 45 times sine of 30. Step 3, we just have to plug in all those values we know by heart from the unit circle. And finally, step 4 is just the cleanup crew. We multiply everything out and get a common denominator to simplify the expression. And there you have it. After all that simplifying, the exact value for the cosine of 75 degrees is the square root of 6 minus the square root of 2. All of that over 4. We just found a totally precise answer for an angle that wasn't even on our unit circle. How cool is that? Let's do another one real quick just to make sure this is sinking in. What about the cosine of 15 degrees? Well, we can write that as a difference, right? 45 minus 30. So this time, we use the difference formula. Our setup looks almost identical. Cosine of 45 times cosine of 30. But this time, it's plus sine of 45 times sine of 30. See that sign flip in action? A difference in the angle gives us a sum in the formula. Now, I really want to hammer this home because that sign flip is, without a doubt, where almost everybody gets tripped up when they're first learning this. It is the #1 mistake, so let's focus on a super simple way to make sure you never, ever make it. Here it is. This is the best way to remember the rule. Just say this to yourself. Cosine is contrary. That's it. It's short, it rhymes, kinda, and it's always true. If you see a plus sign inside the cosine, you're going to use a minus in the formula. If you see a minus, use a plus. Always remember, cosine is contrary. And this is why it's so critical. It is so tempting to just look at cosine of alpha plus beta and think you can just distribute it, make it cosine alpha plus cosine beta. But you absolutely cannot do that. That is not how it works. You have to use the full formula with those matching pairs and that all-important contrary sign. Okay, so why are we spending all this time on this? Besides passing your next math test. Well, believe it or not, these formulas are actually the engine behind some incredibly cool real-world technology. Yeah, seriously, think about a giant robotic arm on a car assembly line. Every single joint on that arm, The shoulder, the elbow, the wrist, it rotates by a certain angle. To figure out the exact final position of that welder or gripper at the end of the arm, the robot's brain has to combine all of those individual rotations. And it does that using something called rotation matrices, which are built directly from, you guessed it, these cosine sum and difference formulas. And that, really, is the magic of what we've talked about today. We started with a problem that seemed impossible, finding the cosine of 75 degrees. And with the right formula, it just became a simple calculation. It really makes you wonder, doesn't it? What other huge, complex problems out there are just sitting around, waiting for us to find the right formula to make them simple?